let's talk about how we can use the discriminant to find out information about a quadratic equation. For example, let's say x squared plus 2x plus 1. And I want to know, when is that equal to 0? Specifically, let's say we don't care the exact answer. We just want to know how many are there. Well, that is a perfect example of when we can use the discriminant. As we know, the discriminant is b squared minus 4ac. We know that if it's positive, we have two solutions. If it's negative, we have two imaginary solutions, and if it's 0, we have one solution. So let's see what it is. So here, we know that a is 1, b is 2, and c is 1. So when we plug this in, we get b squared is 2 squared minus 4 times a is 1, and c is 1. So 2 squared is 4, minus 4 is 0. So in this case, the discriminant is 0. So we have one solution. We didn't care what that solution is, and so we can be done at this point. However, I would like to continue, and let's see what would have happened if we had instead used the quadratic formula. So, to remind ourselves what the quadratic formula is, that is that x equals negative b plus or minus the square root of b squared minus 4ac. And all of that is all over 2a. If I plug this in, I get negative b, so b is 2, so negative 2, plus or minus the square root of b squared, which is 4, minus 4 times a is 1 times c is also 1. And all of that over 2a, well, 2 times 1 is 2. So we get negative 2 plus or minus the square root of, now we just have 4 minus 4. Well, that's clearly 0. All over 2. So this is just negative 2 over 2, which is negative 1. Because when I take negative 2 plus or minus the square root of 0 is 0. So negative 2 plus 0 is negative 2. Negative 2 minus 0 is also negative 2. And this is why we only have one solution. Because if it's 0, we're not actually adding anything. And we only have our one solution, which is negative 1. So to recap, if we are only interested in how many solutions, we can just use the discriminant, which is just the one little part of the quadratic formula. If we care what the actual answer is, we'll have to use the entire equation.